Hello everyone, welcome back to another kickoff video. This time we're going to take a look at assignment 3. Assignment 3 is called String Tango, and in this assignment you will have to implement a very basic text editor. There's a certain set of commands that the user can choose from to manipulate this text, and the main focus and the learning goal of this assignment is dynamic memory. In this assignment you will have to allocate, resize and free strings that are stored on the heap. The deadline for A3 is the 10th of December at 6 p.m. So there are roughly 3 weeks left, and assignment 3 is worth 18 points. For the grading, again the functionality makes up 70% of your points. The other 30% are related to code quality. And regarding the deductions, I want you to pay special attention to the violations of specifications. So let's check out Notion, specifically the memory management sections, and make sure to read the first 3 specifications at least. The 4th specification is only relevant starting with A4, but definitely make sure to read the first 3 specifications here, because otherwise you will probably get a deduction. And if you have any questions regarding those specifications, just ask on Discord. There will also be another assignment interview, but this time there will be no coding task. For A3 there are certain assignment specific specifications that we need to pay attention to. At first, the malloc or calloc function and realloc and free must be used. However, if you make proper use of dynamic memory, this specification will almost be fulfilled by default. All strings must be stored on the heap. This specifically refers to strings that are part of a user input. And strings that are manipulated with the commands that the editor supports, the strings must always be stored on the heap. If there is some string that you want to print, for example an output message, that string does not need to be on the heap. You can just write the string directly in the code. Your program must be able to handle user input of arbitrary length. That means that there is no fixed maximum length of user input. Your program really must be able to handle user input that might be, in theory at least, infinitely long. Strings must only use as much memory as necessary. Since all strings are stored on the heap, we need to allocate memory on the heap, and those memory chunks need to be exactly the same size as the string, no more, no less, otherwise you will get a deduction. You will also be asked to sort strings. For that you will have to implement your own sorting algorithm. You're not allowed to use the qsort function. If you do, you will get a deduction. Before I take a look at the demo of the program, let's quickly cover the flow of the program. So at first the user is greeted with a welcome message, then the user inputs some text, and this is the text that the user can manipulate with a certain set of commands. The commands are append some text, search and replace the substring, split and sort, and the unique command. How those commands work exactly I will let you know in a second, and this process is repeated until the user quits the application. For A3 you really need to pay close attention to how white spaces are handled. So white spaces are always part of the user input and they should not be removed or anything. Also, the user input is case sensitive. That means that you need to respect the upper and lowercase letters of the user input. And now it's time to take a look at a quick demonstration of the program. I have switched to the virtual machine and I have opened a terminal in one of our reference solutions. I'll go ahead and type make bin to compile the program, and then I will start the program. So at first the user is greeted by this welcome message here, and then the user is prompted to enter a text, and this is the initial text that we can later on manipulate with this set of commands that are supported by the editor. So let's go ahead and type in some text. This is a sample text, and then the user is shown a list of commands that are available. I will show you each command individually, and if you want to select a command, we need to just type in this letter next to the command. As I mentioned earlier, the user input is case sensitive, so if I wanted to select the append text command now, and if I type in an uppercase A, this will not work because this is not recognized as a command. But if I type in lowercase a, confirm with enter, this now starts the append text sequence. The way the append text command works is by it asks the user for a substring, and this substring is appended as is to the current text. I will show you how this works. So let's type in some text that will be appended and some words. And whenever a command completed successfully, it will print the updated current text and prompt the user again for another command. So we see here that and some words was appended exactly as is to the current text without putting a space or anything like that between. So we see here there's no space between text and the word and. I can also show you that white spaces are kept as part of the input. So let's go ahead and type in some spaces, a few letters, maybe a few more spaces. And we see here that the spaces are really not removed. Let's check out the search and replace command. Search and replace command works by at first searching for a substring, and all occurrences of that substring are removed with another substring that is chosen by the user. So I will show you. Select this command. Please enter the substring to search for. There is no space between text and the word and, so this kind of bothers me. That's why I want to replace it. I'll type in text and I want to replace it with text space and. And we see here that word really was replaced with text space and. I can also replace just letters. So let's go ahead and just replace lowercase I with uppercase X. And we see that all occurrences of lowercase I were replaced with uppercase X. If you search for a word that does not exist, or search for a substring that does not exist, you will get an error message, substring not found, and the user will be thrown back to the main menu where the user can choose another command. Let's take a look at the split and sort command. So the way split and sort works is it first splits the current text into words, where a word is a sequence of letters separated by space. So each of those sequence of letters are considered words. And once they are split into words, they are sorted in alphabetical order. And once they are sorted, they will be joined back into a single string where the words are combined with exactly one space separating those. I'll show you how this looks like. This string is now sorted. Uppercase letters come first, then lowercase letters, because this is how they are found in the ASCII table. And if there are words that start with the same letters, always choose the shortest word first. So A is shorter than and, that's why A was chosen first. And you see here that spaces are removed as well. We had a couple of spaces between X, Y, Z and words, but since spaces themselves are not words, they were not split properly, they were just discarded. And when the sorted words were joined back into a single string, there's only now one space that separates those words. If we want to quit the application, we can either choose the quit command by just typing Q, pressing enter, and this quit command prints the current text one last time and then it terminates the program. There's another way to terminate the program by typing quit or the word quit exactly as it is written here, no spaces and no uppercase letters. This word quit is valid at each prompt to terminate the program, and there is no current text printed or anything. The program is terminated immediately, as you can see here. I want to start the program one last time because I want to show you the unique command with an example that showcases the command rather well. So let's go ahead and type in word text word and maybe text again. Now I enter the unique command. And the unique command works by removing duplicated words. And what is special about this command is that the way duplicated words are found is case insensitive. So that means that word here in all uppercase and word in all lowercase in a case insensitive way is identical. And whenever we find a duplicated word, we remove all duplicates and always keep the first occurrence. That's why word in all uppercase letters is chosen. Same for text. Text with a uppercase T and text in all uppercase in a case insensitive way is equal. Text, or this text here, is the first occurrence. That's why this text is chosen and this text is considered a duplicate. Now let's quit the application again and let's take a look at the test report. As always, there are public and private test cases. There are 14 public test cases and 15 private test cases, if I'm not mistaken. And the public test cases you can check yourself by running make test. I have already done this and opened the test report, and I now want you to pay attention to this mem usage errors and mem leak sections. Maybe those sections were not really a problem for A2 and A1, but for A3 this might really be something that you need to look into. So even if you have 100% diff for a test case, if there are mem usage errors or mem leaks, this test case will not give you full points. So whenever you have anything other than 0 here, just open the memory analyzer log and read whatever this is here. This is the output generated by a program called Valgrind. And Valgrind lets you know if, for example, you read from or write to a memory chunk that no longer exists or maybe never even existed in the first place. In this case here, we have a memory leak. How do we know this? Because it says in use at exit 5. So when our program terminated, we still had memory allocated on the heap that we did not free. Also says here 5 bytes in 1 blocks are definitely lost. And it even tells you where this memory leaks, so where the memory that was not freed, where you have that allocated in your program. You see here this core stack, so this is a sequence of functions that was called when the memory was allocated. We see that in the main function, in our implementation file at line 401, we called the function editor. In the function editor at line 359, we called getString function. In this function, we called reallocate string function. And in here, it used the realloc to allocate some memory, but the memory that we have allocated here was not freed when we terminated the program. And now the only thing we need to do is to debug why whenever we allocate memory here, it was not freed when the program was exited. And so whenever you see memory errors or mem leaks, make sure to check out the Valgrind log, try to fix it yourself to get the full points for the test case. And if you have some problems reading this Valgrind output, just let us know on Discord and we will help you. Okay, back to the slides. There are a couple of example outputs on the slides that you can take a look at if you want, but I'm just going to skip them because I've already shown you in the demo. This already brings us to the end of this kickoff video. As always, if you have any questions, make sure to ask on Discord in the A3 forum. There will be a question hour at the 5th of December. The exact time will be announced on Discord. Therefore, always make sure to check Discord for announcements, start early, and do write the code on your own. I wish you all the best for A3, and we'll see each other again in the next kickoff video. Goodbye, everyone.